So in the example I just gave you guys, we're looking at a triangle with 3 side lengths and to see how many you could make. So what I've done here is I've created kind of 3 sets of lines that are the same. So these 2 lines are the same length, these 2 green ones are the same length, and the 2 red ones are the same length. And I'm going to try and create 2, the goal here is to see if I could create 2 different triangles using those side lengths. If I could create 2 different triangles, then we could say that these 2 triangles are not congruent. That means they're not the same. So let's change orientation. Orientation is which way things are facing. And let's start with this one on the left. So I've got these 2 side lengths, and in order for that to meet this, I have to move things around. So that's going to tell me that I have to actually make it like this. There's no other way that I can connect that one here. Let's try it from the other direction, the other side. And if I go over there, so if I try to make something a little different than this one, maybe, like if I try to make it more like a right angle here, well, that's not going to work because this green one's not going to match. If I try to maybe make a thinner angle, create an angle that's really, really small that clearly this one doesn't have, well, that's not going to work either. It looks like I'm going to have to bring it to this location here. Now, are these 2 the same? Let's take a quick peek with the, they're clearly not facing the same direction, and they're flipped. One is a flip from the other one. But let's check the angles. And I'm a little bit off because of the vertices where they meet aren't exactly lined up because they're a bit thick. These aren't truly lines. This is telling me this is about 100 degrees here. I'm going to check this one as well. And this looks to be about 100 degrees as well. So both of these 2 angles here, this angle is the same as this angle here. Let's check this one over here. This is telling me it's about 30 degrees, and I'll check this one, which looks to be the corresponding angle. And that's also about 30 degrees. So this one, I'll put 2 lines. That angle seems to be equal to that angle. And then the final one, I'll check here, looks to be about 60 degrees. And this one also right around 60 degrees. And again, it's just off because of the fact that these aren't really thin lines. So I've got here 3 lines that are the same length, the black lines, the red lines, and the green lines. Normally you would have a measurement to indicate that they're the same. In this case I'm using colors. And you have 3 angles that are the same. This angle here is equal to that one, and this angle is equal to that one. And they're corresponding angles. And that means that we've got the black line here and the green line here. Where they touch, the adjacent point, the vertex where these 2 touch, this angle corresponds to this angle where the black and the green line meet. And where the black and the red line meet, this angle here corresponds to where the black and the red meet here. And those 2 are equal. And then these 2 also correspond and are equal. So we have all angles and all side lengths equal. So in this case, we can actually say that they're congruent. They're the same in size and shape. It's just a matter that they've been flipped and maybe rotated a little bit from one another. So we can actually conclude, if we were to try this many different ways, we would find that anytime we are given 3 side lengths for a triangle, this only applies to a triangle. Anytime you're given 3 side lengths for a triangle, there's only one way that you could draw that. And so any number of triangles, let's say I told you to make 10 triangles, draw 10 triangles with the measurements I told you, 5, 7, and 9 centimeters. If I told you to draw 10 triangles with those measurements, they would all be the same. They would all be congruent. So we have a rule now, and that rule is called the side, side, side rule, because we have 3 sides that are given to us, or that we figured out are the same in length for 2 or more triangles. And the short form is SSS. And the key here is how to prove that, in writing. Okay, normally we would have labels here, like A, triangle A, B, C, and let's say triangle D, E, F. And here's how you write it down, and this is very, very important. This is the proof. I'll try and do this nice and large for you. So, for the proof, what do I write down? I know I'm going to need 3 sides because this is the side, side, side rule. So I'm going to write that down here. Side, side, side. So AC is this side over here. So I write down AC equals, and then I need to find the corresponding side. Well, we have this side here. If this is A over here, A is touching the red. this black line here, AC, is touching the red, and that's where A is. So I have to find out whether it's D or F that corresponds to A, and it's actually F. F corresponds to A, so it's side AC equals side FD. Whoops. There we go. And that's my first side. And then my second side, I've got BC. Let's try BC in my left triangle. Side BC, B corresponds to E over here because it's the red and the green touching each other, green and red. So BC equals ED then. And then my last one is AB, and A corresponds to F. So AB is equal to FC. And those are my three sides right over there. Now, what we need on top of that is a reason why each of those is correct. And in this case, we were told that these three lines are equal. We were told that this line equals this line because it's black, this equals this because it's red, this equals this because it's green. Normally, you would be given those measurements, like you would be told that AC equals 10, or it would be written down. So we write down our proof, which is given in this case. We just write down the word given beside each of those lines here. And then we can make a final statement at the end. We do these three circles that make a triangle, and this stands for what? Does anybody know what that stands for? When we draw that, yes? No? What does that stand for? Therefore. So when we put three little circles together like that, it stands for the word therefore triangle. And I'm going to label it A, B, C. And how you label is important. And congruent you can do like this. 2 lines, an equal sign, and then a little squiggly, or 3 equal signs. 3 lines would be fine too. A, B, C, and how you label is important. A corresponds to F. B corresponds to E, so it's F, E, and C corresponds to D, so it's F, E, D, not D, E, F. And then we write S, S, S. So let's see if I can zoom in there so you can see that closely. Whoops, a little too much. So the proof. AC equals FD, given. BC equals ED, given. AB equals FC, given. Therefore, did I make a mistake?
Yes.
Which one?
FC.
FC.
It's FE.
Sorry?
FE to FE.
This one should be E?
Yeah.
F.
Oh.
Yes.
E, thank you. AB equals FE, thank you. Now I'm no longer perfect. So therefore, triangle ABC is congruent to triangle FED. So this means is congruent to, and this means therefore. And that is an explanation of the side, side, side rule. The recap is, if you're ever given 2 triangles and all 3 sides are equal, corresponding sides, then those 2 triangles must always be congruent.